we want to differentiate the following. Now remember, if y is equal to ax to the n, that means that dy dx is equal to nax to the n minus 1. So the power here drops down in front and multiplies, and we reduce the power by 1. If we're given f of x, then the dy dx equivalent is f dashed x. So f dashed x is the differential of f of x. So if y is equal to x squared, then dy dx is just going to be drop the 2 in front, 2x, reduce the power to 1. We don't normally write the 1, so it's just 2x. Here dy dx is 2 comes down and multiplies to 3, so that's 6, and reduce the power to 1. Here 7 comes down and multiplies to 10, so we get 70, and reduce the power from 7 to 6. Here we have dy dx is equal to 4 times 5 is 20, and reduce the power from 4 to 3. Now consider y is 3. Remember, that's the same as having 3x to the 0, because of course x to the 0 is 1. So when we differentiate, the 0 drops down in front and multiplies, and it doesn't matter what it multiplies because 0 times anything is just 0. Now another way to look at that is to consider the line y equals 3. It's a horizontal line and therefore its gradient is 0. So we would expect the gradient function to be 0. Now y is 3x. Remember that that's 3x to the 1. We don't normally write the 1. The 1 comes down in front and multiplies, so we get 3. X to the 0 when we reduce the power, and x to the 0 is 1, so dy dx is 3. Now if we think about the line y equals 3x, it has a gradient of 3, so we would expect the gradient function to be 3. Here we have f of x is 2x cubed over 3. You could also think of that as being 2/3 x cubed. So when we differentiate, and note that this is still f of x, but now I differentiate, I write f dashed x. It's really important to get this right. The 3 comes down in front and multiplies, and then we drop the power by 1. These 3's cancel, so we end up with 2x squared. Here you could think of this as 1/5 x cubed. You don't have to, but it's a good way of thinking of it. So f dashed x, drop the 3 in front, so 3 times 1/5, and reduce the power by 1. So that's 3/5 x squared, or 3x squared over 5. So you can see from there, going from here to here, that because the bottom is just a constant, we could have just differentiated the top and left it over 5.